Good morning, everybody. Let's go ahead and get started. My name is Chetan Kapoor. I'm part of the product management team with EC2. Before we get too deep into the session, show of hands, how many of us are new to the cloud or EC2? A small portion, okay. And how many of us are already using EC2? Okay, a decent majority, great. So this session is gonna get into some of the details around how EC2 works. And it's going to be applicable for all of us who are either new to the cloud or already using EC2 and want to learn a little bit more about how it actually works. Just to start from the baseline, EC2 stands for Elastic Compute Cloud. It's a web service that makes it easy for our customers to provision compute capacity via just clicks in a console or simple API calls. And in this session today, we're going to talk about how EC2 works, review different offerings, talk about different use cases that they're targeted for. We'll also highlight some of the new EC2 features and product launches that we have introduced this week and weeks leading up to reInvent. So let's dig in. So our discussion today, or our talk today, is going to be broken up by these 4 sections. We're going to talk about resources, primarily EC2 instances, but we'll also very quickly touch upon storage elements associated with EC2. Networking is a really big part for EC2. We'll discuss availability, the concept of regions and availability zones, and how to build resilient applications. Talk a little bit about management, and then we'll conclude by talking about purchasing options and how to optimize your spend on EC2. We're going to spend about 70% of our time talking about instances, because that's core of what EC2 does. And then we'll quickly breeze through the rest of the sections. Please bear in mind that discussions around building fault-tolerant, highly resilient applications, managing your EC2 resources and purchase options, they all by themselves can be like hour-long level 200 content. So the concept behind this presentation is to give you guys second-level insight into what these things are, and then you can follow up via other talks at reInvent or some of the getting started content we have on our website. So let's dig in. So EC2, like I mentioned, is Elastic Compute Cloud. Although sometimes we position cloud as being this nebulous thing that doesn't have any walls or boundaries, reality is that it does go back to racks of compute servers that are deployed in our data centers, right? So at the highest level, one AWS region contains multiple availability zones. Each availability zone has its own power domain, it's its own networking domain, it's got own cooling subsystems. And each availability zone consists of multiple data center buildings. So that's the full construct of regions and availability zones, as we call it. These racks of compute servers that we deploy very often have dozens of servers that are part of the rack itself. And each server has 4 critical hardware resources that are provisioned as instances. So we have compute, memory, storage, and networking. So a host server contains these core resources, and then we use a hypervisor to provision and slice up these resources and provide them to you as virtual machines, which we call as instances. So when you launch an EC2 instance, you're running on a virtualized portion of a server that is deployed in an AWS region and is available in an availability zone. So back in 2006, when we launched EC2, our first instance was M1. It provided access to one virtual CPU running at 1.7 gigahertz and a couple of gigabytes of system memory. So besides giving customers the ability to launch compute resources through a web service, there were 2 other key tenets for EC2. One was we enabled customers to pay only for what they used. So if you needed a virtual machine or instance for a few hours, that's what you did. You just spun it up, you paid for that time you used it, then you shut it back down. The second one was we gave customers the ability to easily scale how many VMs or instances they were able to use. And again, back in 2006, a lot of people considered this as revolutionary because the only alternative at that time was for customers like yourselves to rack and stack hardware, right? So you would build out data centers, you would actually provision racks and servers and set up the software and have people managing the compute, networking, and storage elements of your data center. So since then, our offerings have evolved dramatically, mainly because of the feedback that we have been receiving from you guys. M1 was a really good instance for us to get started with. It had a decent ratio of all the compute resources. But as more customers started adopting EC2, we started getting more feedback about, well, for my this particular application, I need this other configuration, and for this other one, I need a slightly different configuration. So we have been evolving our portfolio pretty quickly, trying to keep pace with your requirements. In 2017, we introduced our Nitro system, which Werner talked about in his keynote, and I'll also go into some detail in this section. And in 2017, there was an inflection point where the amount or the number of EC2 instances that we have been able to offer for our customers, such as yourself, has really accelerated. And we'll get into some of the details around the Nitro subsystem. So today, as we speak, we have more than 270 instance types available for you to use. Again, going back to 2006, M1 instance, like I talked about, 1.7 gigahertz, 1.75 gigabytes of RAM, some local storage, 250 megabits of networking bandwidth, and this was launched by a blog post from Jeff Barr. And since then, our portfolio evolved very, very dramatically. So today, as we speak, we have instances that go up to 4 gigahertz of clock frequency in form of our Z1D instances. We have instances that offer up to 24 terabytes of instance memory. We have storage instances in the form of i3EN that provide 60 terabytes of NVMe storage, or D2 that provides 48 terabytes of local storage in form of a rotating media drive, so really optimized for cost per gigabyte. And then we have increased our networking bandwidth more than 10x by going up to 100 gigabits per second on per instance type. And our ability to fulfill your needs to the best possible ability with respect to instance sizes and the pace at which we are innovating through the Nitro subsystem has allowed us to maintain our position in the market where when you look at the vision and the ability to execute, AWS is leader in the infrastructure as a service Magic Quadrant by Gartner. And if you would have been tracking this Magic Quadrant over the last few years, you would have noticed that there are fewer and fewer players on this chart. It's mainly because a lot of companies are realizing that it's hard to kind of operate at the scale that our customers are expecting us to operate and offer the features and capabilities that AWS is offering. All right, so let's jump into instance characteristics. So I mentioned this earlier. There are 4 key hardware resources in an EC2 instance: CPU, memory, storage, and networking performance. And each instance family provides a different ratio of these resources targeted for particular applications. So let's talk about M5, for example. M5 is part of our general purpose instance family. It provides a healthy or a good balance of CPU memory, networking resource, storage options, and networking performance. The number 5 represents the generation of that family in our portfolio. So as silicon providers such as Intel or AMD come out with new generations of processors with new features and capabilities, we introduce new generations in the same family. So in the case of the general purpose family, M5 is our most recent instance. The letter D or the letter following the number typically represents variations to that core instance, where we might have options with the local storage or options with a different processor, like Intel versus AMD, as an example. The extra large represents a t-shirt size. It defines the amount of compute resources you have in an instance. And we scale up or down based on this t-shirt size. So for example, a 2 extra large, or 2XL as we call it, is going to have twice the resources as an extra large, but at the same ratio as what the extra large provided. So besides giving you options for different instance families, we have also been innovating on giving you multiple options on the processor types. We've got a really good relationship with Intel, and most of our instance families are based on Intel processors. But last year we introduced, and we were first in the market to introduce AMD EPYC-based processors. And we also introduced Graviton processors in the form of our A1 instance. And this is geared around giving you the ultimate flexibility in right-sizing the EC2 instance for your applications and optimizing your cost. Now let's talk about software a bit. So we talked about EC2 instances, that these are virtual machines that are running on compute servers in our data centers. What runs on these EC2 instances? Well, we use a term called Amazon Machine Images, or AMIs as an acronym. And AMIs contain the host operating system. So this could be Linux, this could be CentOS, this could be Ubuntu, this could be Windows, along with the hardware drivers that are needed for that EC2 instance to function at optimal performance, coupled with whatever software that you're bringing to the table, whatever software that you need for your application. So that's what an AMI contains. And there are different ways you can build your own AMI. For example, you can start with the base image that Amazon provides. So we provide Amazon Linux, Amazon Linux 2 images. We provide Windows images. And then you could take these images, which come pre-packaged with drivers that are optimized for instances, and add your software on top of them, right? Or you could start by using a marketplace offering where our partners provide pre-packaged AMIs for specific functionality, ready to go. You can just click and run them on an EC2 instance of your choice. An example might be that if you are trying to build a network appliance and you really like the capability of a Cisco product, then you could go into our marketplace, search for Cisco, find that offering that you like, and deploy it on an EC2 instance, and you're up and running right away. The third option is you can actually build your own or import your images. We provide a service called VM Import, where you could target it to a VM that is running in your data center and can replicate that VM and create an AMI available for you to launch an EC2 instance with. By the way, quick fact that VM import service also allows you to export the AMIs from AWS. So for whatever reason, if you wanted to take an AMI that you have on AWS and you want to export it and you want to write it on-prem, you can do that too. So for some of the folks that are new in the audience, new to cloud in the audience, let me give a quick demo of how quickly I can launch an EC2 instance. Okay, I'm going to switch. Give me. Okay. So when you log into your AWS console, this is the experience you'll see. You can find EC2 by clicking on the Services tab and locating EC2 under Compute. And you can see all the rest of the services that are available for you to use. Or you could just simply search for EC2 here. In my case, since I've used EC2 before, it's showing under the recently visited services. I click on EC2, get into the EC2 console. So in this case, I'm targeting our Oregon region. You can see this on the top right of my screen. And I can launch an instance by simply clicking on this button. Selecting the AMI type that I want to launch this instance with. And then you'll see all the different instances that are available in the region for me to launch that Amazon Linux AMI with. I'm going to narrow down this list to pick general purpose. And then I'm going to scroll down to pick M5 instance. Let's pick M5-2XL, which comes with 8 vCPUs. There's some advanced configurations associated with these instances. In the interest of time, I'm going to skip over these and just stick with the default values. This defines the EBS volume that is going to be associated with my instance. And this volume is actually going to host my operating system or the main boot drive of the instance. You could add tags if you wanted to. Security groups is a pretty important setting. It actually defines the networking rules with respect to what an instance can talk to and who can it talk to. So in this case, I want to show you guys how I can SSH into that machine. So my default security group allows for a TCP/IP connection on port 22, and right now it is open to the world. I can SSH into this machine from any IP address, but you can lock that down and limit it to the domain of your company if that's what your security posture requires. It's giving me a couple of notifications that I'm going to be charged for this instance, and then it is also warning me that my security group is open to the world. And like I mentioned earlier, the recommended practice is for you to limit your security groups to IP addresses that you know your users are going to be SSHing into the machine from, right? And I'm going to go ahead and simply click on the launch button. This screen is going to ask me for a key pair. The way we do this is when you set up your account for the first time, there'll be a file that is created that needs to be on the local machine for me to actually SSH into that instance. If I don't have it, I can't SSH. So this is the second level of security that we provide in order to make sure that customers have authenticated login sessions with their instances. So I'm going to click. And then it gives me a message the instance is launching. I go back to my dashboard and I hit refresh. And within 10 seconds, my M5XL, 2XL in this case, with Amazon Linux is running. Let's try and connect to this. You have multiple different options. Since this is a Linux AMI-based instance, I can use my favorite SSH client to log into this machine. As a part of this demo, I'm going to select the EC2 Instance Connect, which is going to allow me to connect to this instance using a browser-based connection. And if I hit connect, oops, this is what happens when you VPN in. Apologize. Give me 1 second. Get back into this. Okay. I'm going to get back into my connection, click EC2 Instance Connect. It's browser-based. And just like that, I've been able to SSH into my Linux instance. And if I do ls-cpu, it's going to tell me details of the processor that I have in this instance. And you can see I have 8 vCPUs. This is running on an Intel Xeon Platinum 8175 processor running at 2.5 gigahertz at this particular frequency. Great. So that's a really simple way to just log into your EC2 or launch an EC2 instance and log into it. A lot of our large sophisticated customers, instead of using a console, use a command line interface or program their applications to directly launch EC2 instances. So here's a simple way. Here's a simple example of how to do this. I've already pre-configured my PowerShell by giving it the right access keys. And if I run the simple command where it's a run instances command where I'm defining the type of instance I want, the image that I wanted to load with, and which region I'm targeting. And as soon as I hit enter, within seconds, it's going to go ahead and launch that VM. If I refresh this page, since again I was targeting that Oregon region, here's the second instance type that I just launched using a CLI, already available for me to go ahead and connect and use in my application. So great. It's a really simple example, just to demonstrate the fact that it's pretty straightforward for customers to launch EC2 instances, configure them, and you can do this using the console. You can use this using a command line interface. And as I mentioned earlier, you have APIs available through our SDK for popular IDEs that you could build into your application itself. Great. So let's jump into instance types, and we're going to be really quick in this section because there's a lot of depth here. Our general purpose instance types are targeted for workloads such as web applications, web servers, gaming servers, dev test environments, caching fleets. Our M5 instance, which is the latest generation, is our workhorse in this category. It is available with 4:1 ratio of memory to vCPU. That means for every vCPU that we have in the system, there'll be 4 gigabytes of system memory that is available in that instance. What we have realized over the years is, although we provision all these vCPUs as part of these VMs, a lot of customer workloads are actually not using these CPUs. So we took that as an opportunity for us to give you an instance family that is optimized on cost per performance. And we came up with our T series of instances, with T3 being the latest one. And the way T3 works is it provides you with a really generous baseline performance of CPU frequency at a lower cost than M5 family. And if your application needs to burst above that baseline, you can do that through what we call as CPU credits. So T3 is a really good instance for applications that are not super sensitive on CPU performance and can help you lower your costs noticeably over M5 instances. Last year, we introduced our first ARM CPU-based instance. These are based on processors that we have built. These are called the Graviton processors. The instance we launched last year, which is the A1 instance, has a 64-bit ARM Neo processor, and our customers have been able to save 45% over their M5 and T3 equivalent instances. Again, since these are ARM-based, you have to have applications that are compilable and deployable on an ARM-based architecture instead of relying on an x86 architecture. So that's what the portfolio looks, M5, T3, and A1. Earlier this week, Andy announced that we have launched instances with our newer generation of the Graviton processor, the Graviton 2 processor. It is, again, a 64-bit processor, but significantly higher performance than the A1 instances. It's based on a 7-nanometer silicon fabrication process, which is the latest in the industry. Provides up to 64 vCPUs and 20 gigabits of networking capability, and 7 times more performance than our A1 instances. And these processors are going to be available in the form of M6G, R6G, and C6G instances. M6G is available in preview today, so you could search for it on your on our website. Look for it on our website and request for a preview access. R6G and C6G are expected to be available in the first half of next year. All right. So that was general purpose instances and general purpose workloads. There are a lot of applications that are super sensitive on the amount of memory that is available in that instance. This could be caching tiers that are on top of databases. This could be really large instances with a lot of system memory that host the entire database in the memory, and also appropriate for big data analytics. These instances provide more CPU memory than what our general purpose instances provide. So in the case of R5, it provides an 8:1 ratio. That means for every vCPU, you have 8 gigabytes of system memory. We have built on R5 to provide our X1 and X1E instances, with X1E offering 32:1 ratio of memory to vCPU. And then lastly, over the last year, we have introduced our high memory instances that go up to 24 terabytes of system memory, and they're targeted to run SAP HANA workloads. To contextualize this portfolio of high memory instances, you'll see R5 goes up to 768 gigabytes of system memory. X1 and X1E collectively go up to 4 gigabytes of system memory, and then the high memory instances go up to 24 terabytes of system memory. And customers can not only scale up using these different sizes, they can also gang up multiple instances together to create scale out instances with much more system memory. All right, so let's talk about compute-intensive workloads. These workloads are very different, well, I shouldn't say very different. They're noticeably different than the general-purpose workload, and they are sensitive to how fast the CPU can run. What is the frequency it is operating at? This could be batch processing, HPC applications, or video encoding, where applications are sensitive to just this raw CPU performance. So in our portfolio, we have our C5 instances that provide 2:1 ratio and up to 3.1 gigahertz of CPU frequency. Z1D is available on the high end, which goes up to 4 gigahertz, as I mentioned earlier. It provides more vCPU more memory to vCPU than our C5 instance. The next category is storage intensive instances or storage intensive workloads. They can be broadly broken up by workloads that need high I/O or high ops. And the second category is workloads that need just a lot of sheer data storage. So for the high I/O, it could be high performance databases, real-time analytics. In the dense storage perspective, it could be big data, HDFS, Kafka, or Hadoop-based workloads. And also they're really good for like data warehousing applications with really low dollars per gigabyte for these instance types. So again, a quick rundown into instances in this family. We have our i3 and i3EN that are latest instances in this category, and they provide access to NVMe SSD-based storage. D2 instances provide the lowest dollars per gigabyte in our portfolio using rotating media drives. And then H1 is slightly different variant on D2. It still has rotating media drives, but provides more vCPUs and memory than our D2 instances. The last category of instances that I want to talk about is the instances that support our accelerated computing workloads. What do we mean by that? Well, these are applications that need some form of hardware acceleration in that instance for that particular workload. So this could be machine learning applications where you need GPUs or accelerators that are able to significantly reduce the time it takes to train the models or even deploy them in production for inference applications. This could be high-performance computing. Peter, in his keynote on Monday, talked about computational fluid dynamics as an example. Computational chemistry is another category. Genomics in this is another application type in high-performance computing. And the last key application type is graphics, where if you're providing remote graphics workstations for your internal customers, where customers can log into a virtual machine and use it as a remote workstation. 3D modeling, rendering, AR, VR, and video editing are also application types in this category. So when you talk about hardware acceleration, you just take a step back. There are generally 2 or 3 types of hardware accelerations you can talk about. In context to a CPU, CPUs, we know them, we love them. They're really, really good for general purpose applications that typically have 10 to 100 processing cores that are available. The instruction set, or what you can do with that chip, is predefined by the manufacturer of that chip. So this could be Intel, this could be AMD, or it could be us, in the form of us building our Graviton processors. And like I mentioned earlier, really well suited for general purpose applications. GPUs, on the other hand, have thousands of processing cores. In the latest GPU that NVIDIA has, which is the Volta V100, they have over 5,000 processing cores. Similar to CPUs, they come with a predefined instruction set. But just because of their nature or the architecture where they have these thousands of processing cores, they're really, really effective for applications that have parallelized processing tasks. So this could be like simple concept as matrix multiply, which is a core component of machine learning training and a lot of HPC applications. Or it could be for digital signal processing, such as FFT, again, where there's a lot of math that can be parallelized behind the scene. FPGAs stands for Field Programmable Gate Arrays. And to simplify, FPGAs are nothing but just blank silicon that is user programmable. They have millions of these digital logic cells that you would use a special application to actually program and define a specific function for that chip. Since it is a blank piece of silicon that you need to program, it does not come with a fixed instruction set. That means you as an end user need to know how to program FPGAs. But if you do, since you're coding your acceleration to run in hardware instead of software execution steps, you can actually see a significant performance boost. Some of our customers are reporting 20, 30, 40x performance advantages over running just simply on a CPU-based instance. The last category that I want to talk about is ASICs, which stands for Application-Specific Integrated Circuits, where these are chips. They're not general purpose, but they have been custom designed for a particular application type. And you do that where, when you have a lot of volume for that specific use case, and you know that your customers need that acceleration in order to get the best price performance in the market. But similar to CPUs and GPUs, they actually come with a fixed instruction set by the manufacturer of that ASIC. So looking at our portfolio in this category, we have our P series of instances. These are targeted for GPU compute workloads, such as deep learning training, inferencing, financial computing, and batch rendering. They include NVIDIA's high-end GPUs, such as the Volta V100. You have the G series that are primarily targeted for graphics applications. Like I mentioned, 3D rendering, gaming, remote workstations, AR, VR are the type of workloads that these instances are targeted for. And our G4 instance is the latest in this category with NVIDIA's T4 GPUs as what we provision as part of that instance. And then we also have FPGA instance. We were the first cloud provider to launch FPGA-based instances in the form of our F1 instance, where customers can program FPGAs using programming languages such as VHDL and OpenCL and custom build accelerators for their application. In this category, we announced our first instance featuring our own ML chip that we have built. So we announced the Inf1 instances featuring our Inferentia ASIC. It is targeted for high-performance machine learning inference. What that means is where you have a model that's already pre-trained and you're deploying it in production and feeding it live user data for it to make predictions on what the user data is all about. And it's designed to give you a much lower cost per inference for running these applications in the cloud with up to 40% lower than what we provide in our GPU instances. Great. And the last category type of instances we have is bare metal instances. So bare metal instances, if you guys recall when we talked about EC2 initially, there's a hypervisor that sits over the hardware and virtualizes the compute resources. It slices down into smaller chunks that we provision as instances. We provide EC2 bare metal instances that have no hypervisor. US customers get access to the full server, and you can load up your own hypervisor if that's what your preference is. So all of this capability and flexibility that we have in our portfolio starts with a Nitro platform. So we have been able to launch bare metal instances and increase the pace at which we are delivering these instances to you for your various workloads based on our investment in the Nitro platform. So the Nitro platform, in a nutshell, consists of 3 core components. It's got a security chip in the middle, in the heart of it, which actually is the root of trust for our hypervisors, and it's part of the physical motherboard that we have in the server. We have a Nitro card that offloads a lot of the system management that we need to do in order to virtualize the compute resources. And then we have the Nitro hypervisor. So this is the hypervisor that is super lightweight, is high performance, and gives you bare metal-like performance and allows us to virtualize the full server into smaller VMs. So let's dig a little bit deeper into Nitro. So when EC2 started, this is like prior to 2012, on a single server, we were using Zen as our hypervisor, and Zen has a concept of what is called as DOM 0 or domain 0. In DOM 0, that's where you actually run your core hypervisor stack. So the hypervisor, along with the management services required for partitioning, networking, storage resources, also runs in DOM0. You have a lot of management, security, and monitoring services or microservices that are also running in DOM0. And then you have your hypervisor. So prior to 2012, about 70% of the server resources were available for our customers as VMs. And we were using about 30% or 20 to 30% for running this DOM0 entity, right? So which is all this network partitioning, storage partitioning, resource management, and security services on the same host, which we also call as Droplet. So in 2012, we introduced our C3 offering, where we offloaded the networking capabilities. So again, just to dive a little bit deeper on what this networking capability is, let's assume that the instance has 10 gigabits, or the server has 10 gigabits of networking connectivity coming into that server. We need to partition that 10 gigabits of networking connectivity for all the instances that are running. And we also need to load balance them across all the VMs that are running on the same server. So that's one of the core components of what, in this case, the networking microservice was doing. And in 2012, we offloaded that to a separate accelerator card or separate card that was running on the server. And then we acquired a company called Annapurna Labs. And it's been super exciting to continue with this journey, where we have been slowly and steadily being able to move more and more host features off from the Droplet or the host onto this Nitro card. So today, as a part of the Nitro architecture, we have the networking stack, our storage stack, our monitoring management stack that all have been offloaded to the separate Nitro card that is in our servers. What does that mean for you guys as customers? Well, it gives us the ability to maximize the hardware utilization that we provide in terms of instances to our customers. Bottom line is, the better we can maximize our utilization of the server, the lower cost it is for us to provision these resources and pass on those savings to you as customers. So that's why you would have seen that over the generations that we have, the C5, from C3 to C4 to C5, besides the performance advantages that we're getting from the processors through this Nitro architecture, we can maximize the utilization of the server and pass on those savings to you guys in terms of lower prices. So we have almost 100% of the server resources available as instances, and there's a very tiny fraction that is consumed by the hypervisor. But once we have this architecture where all these management services are offloaded from the Droplet, we can just simply take out the hypervisor. That's how we provide bare metal instances to you guys in form of i3ENs and a lot of different instance types that we have in our portfolio. Great. So to summarize, what Nitro delivers is higher performance, better security, because again, a lot of this, the DOM0 doesn't exist anymore. A lot of those core functions have been offloaded to this other accelerator, the Nitro card, as we talk about, and allows us to innovate faster to provide you guys more instances for the right application, for the right type. One of the feedbacks that we hear from our customers is, there's so many instances. Which one do I pick for which application, right? So we've received that feedback, and we have been thinking about it. And last week or earlier this week, we announced a couple of new capabilities in this space. The first one that I want to talk about is instance discovery. What this does is, if you go into the EC2 console, you now have a really easy way to compare different instances and also look at their capabilities, how many vCPUs, what type of system memory, how much storage they have, along with the price of that instance. You no longer have to shuttle between looking at what's in the console, our pricing pages to understand what the price is going to be. Very simply, you can look at different instance types and compare and contrast the resources between them. So that's going to help you right-size the instance that you need and make sure you're making a conscious decision about cost and you're aware of the different options you have available in our portfolio. The next one that is super exciting is the AWS Compute Optimizer. What this does is, once you have EC2 instances running in our portfolio, let's assume you have tens of instances you're running for your application, maybe hundreds. In some cases, or many cases, customers are running thousands of instances. AWS Compute Optimizer is a machine learning-based service that looks at your CloudWatch metrics. These are metrics that you have access to look at compute usage, like what portion of your CPU you're using, how much network bandwidth you're using, what type of EBS performance you have. So AWS Compute Optimizer looks at all these characteristics and recommends alternative instances that may be a better fit. We talked about how in the case of M5 and some of our compute optimized instances, if the CPU is not busy and it's just sitting there and it's like oversized for your application, Compute Optimizer will look at that trend and make a recommendation that, hey, you might actually be okay if you just downscale your instance. Instead of running a 2XL, you could run an XL and your application would run fine, right? So it's targeted to recommend optimal EC2 instances and scaling configurations for your applications itself. Again, it's really simple to use, available at no cost, and you can take advantage of this right away. Great. So like I mentioned earlier, we're going to spend a lot of time on instances, but let's switch gears and quickly go through the next few sections in this presentation. So storage, again, is a big topic. There are a lot of details here. What I do want to talk about is our elastic block storage, or EBS service. As I mentioned earlier, instances have compute, storage, networking, and CPU as a part of their core resources. The storage resources that are part of that server on which you're running your instance are local to that instance. They're not persistent. That means they're not ephemeral. And data is not replicated by default. So you don't have the ability to snapshot it, but you do have the option to pick between SSD and hard drives, rotating media hard drives. What EBS does is it's a block storage as a service and allows you to attach, detach, and modify logical volumes to your EC2 instance, right? So an EBS volume, if you're a Windows user, you can think about it as the C drive or the D drive that is associated to your computer. Although it might be a single logical drive that you're seeing in your instance, behind the scenes, it's actually backed by multiple physical drives. So that's what EBS does. It's a network-attached block storage service and gives you the ability to create and attach multiple EBS volumes to a single instance. You can snapshot them. You have the ability to pick different EBS types between high performance and high and lower cost by picking either SSDs or rotating media drives. And then, like I mentioned earlier, you have the ability to snapshot your EBS volume. So like if your instance is running with EBS, you can snapshot that current state, and that's stored as an S3, which you can use to either launch instances again or distribute to your customers for scale-out applications. Great. So let's quickly talk about some new EBS capabilities. So first off, we have encryption enabled by default for EBS volumes. We have increased the ability to restore from snapshots, FSR. And we have also increased the throughput that is available for instances for EBS. So our largest instance sizes went up to 14 gigabits of EBS bandwidth. We have bumped that up to 19 for our core instances such as C5, M5, and R5, and some of our GPU instances also over the last few weeks. Great. So that's a quick run through EBS. Again, there's a lot of depth in EBS itself and how to optimize it, what different types of capabilities are there, and how you actually snapshot and restore from EBS. Next, I want to talk very quickly about is networking. Networking is super critical, and there's, again, a lot of depth behind networking. So think about it this way. So we talked about security groups when I was going through the demo. Security groups allow you to define the protocols and the IP addresses, the ability for instances to talk out and for people to connect into that instance, right? So that's just the construct of a security group. Imagine the case where you have your users that are in your offices, in your branch locations, that want to connect to an EC2 instance. So what does that networking connectivity look like from your on-prem to AWS? And how do you manage that and secure that, right? So that's one of the core concepts around EC2 networking. It gets even more interesting when you talk about multiple users in multiple branch locations talking to a collection of instances that might be running in a single availability zone, or if you're building highly fault-tolerant applications where you have multiple instances, a lot of them are talking to each other, they're talking to some of the backend that you have running on-prem. How does that all look like? So EC2 networking gives you the tools and capabilities to manage your network connectivity to AWS and within AWS. The most important concept is the concept of a virtual private cloud, or VPC. Again, it allows you to create logically isolated space or virtual space where you can launch your instances in. So VPC consists of a lot of different settings, security groups being one of them, where you can define things such as, again, what IP addresses and ports are you open to. You can also assign or take away any public IP addresses. So in the case where if you have an application where instances are just talking to each other and you don't want them to have the ability to talk outside of the VPC, you can configure that setting too. So again, there's a lot of depth there, right from security groups to talking about ACLs, ACLs, or NAT gateways, or flow logs. Flow logs is interesting, where flow logs gives you the ability to track the metadata associated with the traffic. So if you have a incoming flow from your on-prem into your EC2 instance, flow logs give you the ability to look at that detail, look at that metadata, and see where the traffic is coming from, what type of traffic is coming. We released a new capability called traffic mirroring, and what it does is the same network traffic that's coming into an instance, you have the ability to mirror that to another instance for monitoring purposes. So again, really cool capability there. So again, lots of depth. Could probably spend another couple of hours just talking about VPC. So a quick recap. We talked about AMIs, which are virtual machine configurations or images that are running on EC2 instances. This could be stopped instances or running them. And then EC2 instances are launched as a part of a VPC, and they have EBS connected as their boot volume. And when you snapshot EBS, that snapshot is stored in our S3, which is simple storage service for backup and DR purposes. Great. So let's jump into availability. Now let's talk about regions and AZs. We have 22 regions across the world, and that maps to 69 availability zones. And we have already announced our plans to roll out 4 additional regions in the next year. Indonesia, Italy, and South Africa being 3 of them. We have our own proprietary network that connects all the regions together. It's a really high bandwidth, fault-tolerant, redundant network that connects all of our regions together. And if you, again, going back to the construct of the VPCs, you can actually configure instances to not go over the public internet when they're talking to each other if they're spread across multiple regions. So if you have an instance that's running in Northern Virginia and you wanted to talk to an instance that's running in Oregon, you can do that, and you can make sure that it actually stays within the Amazon network and not go over a public internet. So that's, again, the concept of regions availability, a really broad footprint for you to deploy your applications at a worldwide scale. So let's jump into some tips and tricks around how to build fault-tolerant applications and take advantage of this infrastructure that is available to you. Let's talk about ELB, which is Elastic Load Balancing. And the concept is pretty simple. Let's take an example of a web server where you're running your website, and it's open to the public, and you're receiving incoming requests, and you're servicing that request using your web server. Let's imagine that the product that you're selling is a raging success, just through the roof, and you're getting a lot of requests coming in for people to load up your browser or your website. So what ELB does is it actually just balances or spreads the workload across a selection of EC2 instances. So all that request is coming in, instead of just all of it going to one instance and just kind of inundating that instance, ELB just spreads that workload so that all those instances are used in a parallel manner. So again, helps you build highly available applications that are fault tolerant. ELB with a combination of autoscaling groups is really powerful. What autoscaling does, it provides a couple of really key functions. One is, autoscaling group looks at your setup that you have in an ELB, and continuously you could have it set up to actually look at the health of the instance. And in a case where if there is an instance failure, hardware errors happen, hard drives die, fans die, autoscaling group will auto-terminate a bad instance and create a new one based on the image that you have assigned it for and add it to the group of instances that are supporting the application. So that's one function. The other one is dynamic scaling. So again, let's go back to that example of you're running a web server and you're getting a lot of incoming traffic that you hadn't predicted for, or it's just very seasonal. You want to account for additional volume coming in. Dynamic scaling allows you to scale the number of EC2 instances that you have in your scaling group based on certain key parameters that you define. This could be CPU load. Like you're looking at CPU load and you say, okay, once the threshold is 75%, I want you to go ahead and spin up one more instance and add it to the pool. And using ELB, since the load is now spread across n+1 instances, the CPU usage is going to come down, and you can start maintaining that level again. Or you could look at incoming network traffic. Like if you're serving, let's say, video content, and there's a lot of video that is going out of AWS into your clients' phones or browsers. You could be looking at network output and say, okay, once my network throughput reaches this value, I want you to go ahead and spin up one more instance and kind of share that load across a wider set of instances. So that's what dynamic scaling in EC2 and autoscaling does, along with the concept of ELB. Cool. So let's jump into management. Again, if you have these resources that are running, we have made it and continue to make improvements to help you manage and your EC2 instances better. If you recall in my demo, when I walked through different stages or different screens to actually launch an EC2 instance, you had to pick the AMI, you had to pick the instance type, you had to configure some additional parameters, tags, you had to configure the security groups. There were a lot of those details. Customers were telling us that they need a simple way for them to define a predefined template that they can use to consistently launch these EC2 instances with. About a year ago, we launched what we call as launch templates, where all these instance parameters, like instance types, EBS volume, AMI IDs, network interfaces, tags, all of that is collapsed into this concept of a template that can be launched using console, CLI, or an API, and it makes it really easy and for customers to provide a consistent experience, manage permissions, apply governance models, and improve the productivity of your developers because they're not going through these details all the time. It's pretty simple. And we've also made it easy where cloud admins or IT admins can define templates, and using identity and access management controls, limit those templates or allow their internal customers to only launch EC2 instances with those templates and nothing else, right? So it allows you to kind of really apply a strong governance model to your EC2 instances. The other thing that we have been innovating over the last 3 or 4 years on is AWS System Manager. This allows you to look at the health of your instances. It allows you to look at the software that's running on EC2 instances and make sure that it's in that state that you would want it to be. AWS System Manager also supports on-prem deployments, where it will give you an agent. You can deploy it on your on-prem VMs and have it tunnel data back into a dashboard where you can look at the health and the software status of not just your EC2 instances, but also your on-prem resources. Again, allows you to make it really simple to track software inventory across accounts, across different instance types, and across cloud and on-premise. It's supported for Linux and Windows. The next thing I want to talk about in this space is License Manager. A lot of customers use third-party software, such as software from SAP, Microsoft, or Oracle, and they need a way to track the usage of these licenses and make sure it's compliant with what their contract requires. So AWS License Manager lets you define these rules, enforce them, measure the usage, and overall just manage access and utilization of these licenses on your EC2 instances. It's seamlessly integrated with AWS System Manager, so the capability that we talked about in the previous slide, and it's available for free to use. It doesn't come with an additional charge. Great. In the last 5 minutes, let's talk about purchase options. So there are generally 4 different ways that you have to consume and pay for EC2 resources. The most common one is on demand, where you just spin up resources and on a pay-as-you-go model, where the usage is actually measured on a per-second basis. It used to be an hour, but about a year ago, we actually, we heard your feedback that there were workloads, there were cases where VMs were not terminating at the hourly boundary, and we changed or updated our monitoring metrics to actually measure usage by the second. Really good for spiky workloads. In the case where you actually have sustained usage, where the instance is continuously running, we provide the ability to reserve instances and get a significant discount from on-demand prices. In many cases, up to 70% discount for a 3-year commitment over on-demand prices. About a month ago, we launched a new concept called Savings Plan. How many of you guys are familiar with Savings Plan? A few hands? Great. Yeah, Savings Plan. I'm super excited about Savings Plan. What it does is it gives you the ability to commit not at an instance level. Like you don't have to commit and say, OK, I'm going to use an M5 XL or an M5 for the next year or next 3 years, right? It allows you to commit to a dollar amount in EC2. Let's say you say, I'm going to spend $1,000 on a yearly basis for 1 year with EC2. Once you set that threshold, Savings Plan will take your instance usage and automatically apply up to a 70% discount up to that threshold that you have set. So in this case, up to that $1,000 mark that you have set for the year. So if all your usage for EC2 and the charges you're incurring up to that $1,000 mark would automatically get a pretty significant discount. And if you go above that, if your usage goes above the 1,000 threshold or the monetary threshold you have set, you'll be charged on an on-demand basis, right? So it really simplifies how to actually optimize your spend on EC2. The last one is spot instances. So with spot instances, we allow customers to tap into our unused capacity. So and if you do that, we get you a discount of up to 90%. The key caveat to keep in mind is spot instances are terminatable, like in the sense, if you launch an instance and we need the capacity to support an on-demand customer or reserve instances customer, we'll take that, get capacity back, but give you a 2-minute warning before we actually do that. So it's really good for fault-tolerant, stateless workloads, and a lot of our customers are successfully using spot and seeing significant discounts over on-demand and even reserve instances. So again, reserve instances, like I said, you can commit from a 1-year to a 3-year term. You can get a pretty significant discount. You do have the option to pick how you're going to pay for these reserve instances. You could pay for it all up front. You could do a partial payment where you can pay 50% of it up front, and the remaining 50% on a monthly basis. Or you could do a no upfront, where you're just charged on a monthly basis for your reserve instances. They also give you the ability to allocate capacity. So if you're buying a reserve instance, you can say, OK, I'm going to pick an M5 XL, and I'll actually, AWS, I want you to reserve that capacity for me so that I'm guaranteed to have that capacity. So through the concept of a zonal RI, we give you the ability to lock in that capacity for that instance itself. Some of our customers, I'm going to skip through some of this content in the interest of time. Some of our customers ask us for recommendations on when do I use which purchase type. The answer to that question is, well, you should use them all. If you have steady-state workloads that are going to continuously run in AWS and EC2, we recommend for you to use RIs or savings plan to really optimize your spend on EC2. For workloads that are bursty, we recommend using on-demand. On-demand gives you the flexibility to only pay for what you need and not be committed to like a 1 year or 3 year term. So that's, again, a really good usage model for spiky workloads. And the last one is Spot. For fault-tolerant applications that can manage their states across instance terminations, we recommend Spot. Again, through the combination of all these 4 purchasing options, you can really optimize your spend and cut it down by 60, 70, 80% over just standard running on demand. Great. So with that, like I said, we quickly walked through EC2 instances, some of the other capabilities around networking, storage, availability management, and purchasing options. And that's it. All right. Thank you so much. Hopefully, you guys had a really good reInvent. And I'm going to stick around for any questions that you might have. Appreciate your time. Thank you.